Hi, and welcome back to my channel. So in this video I'm pretty excited because I have here my very popular Baofeng UV-5R radio. I had this radio for about 2 years and a half, I think, and I always wondered how it is this radio in terms of purity. So does the signal emitted by this radio is clean or not, basically. So of course the question is related to the fact that this unit only costs 25 euros. It is extremely popular. So is it also good or is very bad? So now finally I've acquired all I need to test this with my equipment. So you have here the spectrum analyzer. I have here a dummy load and I have here a sampler to perform the test. So the actual test will be performed in the next video. In this video here, episode 20, I just want to document precisely the setup, okay? Just in case somebody else wants to repeat the experiment, the measurements, well, they can compare it properly, seeing exactly what I'm measuring and how. So, okay, for the moment, the Baofeng goes out of consideration. And let's see how the measurement will take place. So of course the idea would be very simple if we could just connect the Baofeng to the input of the spectrum analyzer and see the frequencies on its display. But unfortunately the Baofeng is too strong. So its output even in low power mode is of about 1.5 watts, which is about 32 dBm. And the limit of the spectrum analyzer is 30, so I cannot connect it directly to the spectrum analyzer. And in any case, the strong setting for the Baofeng is high power, should be of around 4 watts, so it's absolutely impossible to connect it to the spectrum analyzer. So the idea, ideally one would have an attenuator, like a 20-30 dB attenuator, so we could connect it directly to the spectrum analyzer. So here I have an attenuator. In fact, it is a coupler. So it takes an input, here you connect the dummy load, and here you get a sample, which is like the input but attenuated by 20 dB. So that could go here to the spectrum analyzer, but unfortunately this coupler, which is a precision coupler by Mini Circuits, I used it in many of my videos, ZFDC23S Plus, is only rated for about 1.5 watts. So I don't want to risk ruining this device, and so we cannot use it here. So this is why I built this sampler. So I documented it, the construction of this in my episode 13. So this sampler is something I learned about on this YouTube channel. By the way, this is an amazing YouTube channel. I suggest you, if you're interested in RF, I suggest you follow it, by ham radio operator W2AEW. And so it's nothing more than voltage divider, basically. So the input enters here, it goes out here to a dummy load, and from here we get a signal attenuated. So it's not really as good as a proper sampler, because the attenuation you get here depends on frequency quite heavily. It's not fixed at 20 dB. But okay, I'm going to show you what is the response, and then we will use this to reduce the power of the Baofeng and send it to the spectrum analyzer. As a measure of extra caution and safety, I will perhaps use this minus 30 dB attenuator. So this is something from China that the camera cannot zoom properly. So even if this provides probably quite enough attenuation, so the sample port here is very attenuated, I will probably still attach this 30 dB attenuation here to be extremely careful, okay? So I really don't want to damage my spectrum analyzer. And the dummy load that I will touch to this sampler, this port here, is going to be this dummy load that I reviewed and checked in my previous episode, number 19. And this can handle 12 watts. So it's completely fine for this Baofeng that at most can output 4 watts. Okay, so in this video I want to well, let's organize this measurements scenario. Okay, so I've just connected. I decided not to include all the boring parts where I connected the cables and stuff, because it's, you know, it always takes some time, so it's not super interesting. But anyway, the output of the tracking generator is being connected to the input port of this sampler unit. This is directly connected to the output port of the sampler unit to the 12 watt dummy load. And here the output, the sample output of the reduced power copy of the input is connected from here to the input of the spectrum analyzer. Okay, in fact, for the moment I didn't attach the minus 30 dB attenuator that I mentioned before, because the tracking generator is safe here, it does not emit too much power. But still, thinking about the setup I will use later to test the Baofeng, I attach a DC blocker. Okay, this is a good precaution in general. So even if the Baofeng for some reasons is faulty and emits DC power on the antenna, this is going to block it, and so my spectrum analyzer is safe. So okay, I'm now going to basically show you what is the response of this unit using the tracking generator of the spectrum analyzer. So to do this, now I'm going to activate the tracking generators. As you can see at the moment, the spectrum analyzer is set from 1 megahertz to 1.8 gigahertz. Okay, this is the limit of this spectrum analyzer. I'm now going to, let me activate this line. I'm going to activate this tracking generator, and the tracking generator is emitting a signal, which is basically this line, okay? It's a flat signal at minus 10 dB, and so I represented it there. So let's see how it goes. I'm going to set the power to minus 10 dB, where the line is. So minus 10 dBm. Okay, and there we go. Okay, so this is the response of this unit. As you can see, the signal is quite attenuated. So at very low frequencies, the attenuation is of almost 50 dBs. Okay, so here we are at minus 62. So it's minus 52 compared to the line of the tracking generator. And as the frequencies mounts, well, the reduction is in power is less effective. So in particular here, I think we are at the peak, and at 1 gigahertz 0.364 we get minus 35, which is still an attenuation of minus 25 compared to the tracking generator line. Okay, so this is good enough. But anyway, the Baofeng is going to emit in UHF around here, so we get minus 35 compared to the line, and in VHF is gonna be around here, so this is a good minus 45. So yeah, I think with this type of attenuation I don't even need a minus 30 dB extra unit to protect the spectrum analyzer. But okay, so let me now increase or rather, well, yeah, let me increase the strength of the tracking generator to 0 dBm, so 10 times, one division more, so 0 dBm, and yes, so we see that the graph just went up by 1, but still the response is the same. Now I should, you know, the line of the tracking generator is just the top line. Still we get our here reduction here, it's about minus 25, perfect. So yeah, this is the response of my unit here, this sampler. It's pretty cool, and yeah, touching some of these cables, as you can see, creates some yeah, not the best quality cables. Unfortunately, the BNC cables I have are not the best, but still, okay. Okay, fine. Now this is the response on the whole spectrum, and just out of curiosity, let me zoom in a little bit on the frequencies that we care. So I'm going to put center frequency at 140 megahertz. So this is the VHF. So let me put a span of 10 megahertz. And here you can see in this 10 megahertz band, the attenuation of my unit is very flat. Okay, so we don't see this uneven attenuation if we reduce the span. And similar, so here we get about 45 dB of attenuation on VHF. And if I go to 450, so UHF, I get about 50 dBs of attenuation here, looks like, and even in this case it's pretty flat. Okay, yeah, so I'm pretty happy. I think I can just connect the Baofeng to the input of this on this port, and we should be able to see its response. I'm quite excited, and I'm going to do that in the next video. See you later.